Here we're going to cover export policies for our NAS protocols, and strap yourself in because this is going to get quite involved. Export policies and the export policy rules on those policies enable the administrator to restrict access to volumes and qtrees. We can grant no access, read-only, read-write, or super user access. Based on the client, the end host's IP address, the protocol they're using to authenticate, so NFS, the version of NFS and/or CIFS, and their authentication type, which can be none, sys, which is the local user database, Kerberos, or NTLM. On top of our export policies, we can also set standard Unix or NTFS permissions on our files and folders. An export policy with export rules must exist on the SVM for NFS clients to access data. So it's mandatory for NFS clients. By default, export policies do not apply to CIFS shares, but we can turn it on for CIFS as well. Export policies can be specified at the volume or the qtree level. Qtrees will inherit the parent volume's export policy by default, but if you want, you can override it at the qtree level. Each volume has only one export policy. The same export policy can be used on multiple volumes or qtrees if you want to give them the same client access, or different export policies can be used on different volumes or qtrees to give them different client access. Export policies are containers for export policy rules. So we configure an export policy. It contains rules. It's the rules that define the access rights. If a client does not match any rule in the export policy, then access is denied. So if an export policy is empty, no rules in it, then all accesses are going to be implicitly denied. When you create your SVM with flexible volumes, the storage system automatically creates a default export policy called default for the root volume of the SVM, which has got no rules in it, so there's not going to be any access. You must create one or more rules for the default export policy before clients can access data on the SVM. You can also create custom export policies if you want to as well. So you can use the default. If you do, you're going to need to edit it because it's got no access by default, or you can create your own custom policy. So you're going to have one export policy applied to a volume. Inside that policy, you can have multiple rules. The rule order is dictated by the rule index number. So rule 1 is read first, rule 2 is read second, and so on. If a rule matches a client, the permissions of that rule are used and no further rules are processed. You configure export rules to determine client access permissions using the following criteria: the file access protocol, NFS or CIFS, the client identifier, the IP address they're coming in from, and the security type, how they're authenticating. All three criteria must be specified in each rule, and I'm going to cover each of those three types in depth on the next few slides. So the first one was the file access protocol. The options that we specify there are we can select all NFS versions, meaning the client came in over NFS, we don't care which version of NFS they're using, or we can say NFS version 3, or we can say NFS version 4.x, or we can say CIFS. You can enable both NFS and CIFS in the same rule. The second thing to specify is the client identifier. Our available client identifiers are, we can use the domain name, and when we enter this, precede it by a dot. For example, .example.com. We can specify the client's host name, an IPv4 or IPv6 host address, an IPv4 subnet using / notation or subnet mask. So for example, 10.10.10.0/24 in / notation, or 10.10.10.0 space 255.255.255.0 for the same subnet using a mask instead. If we wanted to match all IPv4 addresses, we would use 0.0.0.0/0. We can also use an IPv6 subnet with slash notation, or a net group when we specify a net group, say the name preceded by an @ symbol, for example at netgroup1. So the client identifier does what its name says, it's identifying the client that is requesting access. The last thing to specify is the security type. Clients which match the file access protocol and the client identifier in the rule are granted read-only, read-write, and or superuser access to the system based on their security type, meaning the way that they've authenticated, which I'll cover in detail on the next slide. Read-only, read-write, and superuser rights are granted separately in our rule. Multiple, comma-separated security types can be specified in the same export rule. If we use any and none, which you'll see in a second below, they're always used on their own. So the different types, we can say Kerberos 5, so the client was authenticated by Kerberos 5, or we can use Kerberos 5i, or we can say they were authenticated using NTLM, or we can say they were authenticated by type sys. Sys means it's using local accounts. Any means any client that matches the protocol and client identifier can access the data regardless of security type, meaning we don't care how they authenticated. Type none can be a bit misleading. It doesn't actually mean that the client will not get access. If we want to configure the client will not get access, then use the option down at the bottom there, which is never. If we say never, a matching client cannot access the data regardless of security type. So what does none do? Well, if listed alone, clients with any security type are granted access as anonymous, meaning client, it doesn't matter how they authenticated, like Kerberos or sys or NTLM, they're going to get granted access as the anonymous user. We're going to talk about the anonymous user coming up soon as well in this lesson. If listed with other security types, clients with a specified security type are granted access, and clients with any other security type are granted access as anonymous. For example, if we said on the same line, sys and none as well, then users who authenticated with type sys will be authenticated with their user ID. Users who authenticated with any other authentication mechanism will be given the anonymous user ID. If that doesn't make sense yet, don't worry. We're going to be covering the anonymous user in more detail later in this lesson, and I'm also going to give you some examples so you can see how this all works. There's 3 possible access levels in our export rules: read-only, read-write, and superuser, which is used for clients presenting with user ID of 0, which is typically used by root. We're also going to cover the superuser access level in detail later in this lesson as well. Access level by security type is evaluated in that order. So the export policy will check first, do they have read-only access? Then do they have read-write access? And then do they have superuser access or not? So you need to be careful with how you configure rules, because if, for example, you granted a user read-write access, but you didn't grant them read-only access, then they wouldn't have any access at all, because read-only is checked first. If they don't get read-only access, then the system will stop checking there. Let's have a look at that in a bit more detail. So for a client to get an access level of normal user read-only, then the read-only rule must match their security type, meaning the way that they authenticated. For them to get read-write, then both read-only and read-write must match their security type. So if we'd only set read-write, they're not going to get access. We need to grant them both. For a client to get access level of superuser read-only, then they need read-only and superuser to match the client security type. And for a client to get super user read write, then we're going to need all three: read only, read write, and super user. So remember, you need to specify the protocol that the client is using, the client identifier, which is the IP address they're coming in from, and the security type, which is the authentication mechanism they're using. So our first example here, the protocol is NFS version 3. The client match is matching clients from the 10.1.16.0 network. And our security type, we've got a read-only rule of any, meaning we don't care what authentication type they're using, so they'll all get read-only access. And the read-write rule, we're granting that to users who are authenticating with Kerberos version 5 or NTLM. So let's say that a client at IP address 10.1.16.207 sends an access request using NFS version 3 and authenticates with Kerberos version 5. And another client on 10.1.16.211 also sends an access request using NFS version 3, but it authenticates with AlphaPrep. The client access protocol and IP address matches for both clients. They're both using NFS version 3, which is what we specified as a protocol in our rule, and they're both on the 10.1.16 network, which is what we specified in the client identifier. The read-only parameter allows read-only access to all clients that match the protocol and client identifier, regardless of the security type they authenticated with. Therefore, both clients will get read-only access. However, only client number 1 will get read-write access because it authenticated with Kerberos. Client 2 authenticated with AlphaPrep, which is not granted in the read-write rule. If we had another client at IP address 10.1.17.10, it would get no access unless another rule matches, because it does not match the client identifier. It's coming in from a different subnet.